Hello, my dear friends. I welcome back you to the my YouTube channel. It is Beginners Chemistry, where you can learn the chemistry in the easy manner. Now, today we are going to study about the very important lecture that is what it will be helpful for us in our unit conversion. Mostly, we will use this one in the physical chemistry calculation. Most of the time, the many students, what they will do, even though they know the concept, they will be very understanding to the concept and they will strengthen in the concept. But the little mistake, the small mistake they used to do in the which one unit conversion. So this unit conversion in the chemistry, it will play very crucial role. So in this unit conversion, mainly we used to study in the physics also, but what are the main unit conversions that we are going to see in the chemistry, that I will explain very clearly from the starting, from the basics to the how that units has been came and where we have to use and where in which chapter it will play very crucial role. That all we are going to discuss in our lecture. So let's start our lecture, that is a unit conversions and the fundamental units. Okay, measurement in chemistry and the fundamental and derived units we are going to see. Okay, measurement in chemistry, fundamental and derived units. Here, what is the fundamental units are the and the derived units? First of all, what is the basic units that we are having and what are the fundamental units? If suppose, and why we are going to study or why we are going to use these units means, let's take one point and this is one point. This point and this point, between these two is 4. If I say point between 1 and the point between 2 is 4, if I say, what is the meaning of 4? There is no any meaning, right? If I say point between 1 and 2 is 4, there should be something unit, it should be there. Either it may be the inch or centimeter or meter, etc. Clear? If some unit, if it is having, we can define it. So we can say that the point between these two is 1 centimeter or 1 meter or 1 inch, we can say. Clear? For that one, we are having the units. For that one, the basic units they have taken first mass, length and the time. Mass, length and the time is the basic units they have taken. But later they have realized that, what they have realized that to express the physical quantities, not only these three is, not only mass, length and the time, but other units are also required to calculate the physical quantities. Clear? Now we'll see what is the meaning of physical quantities. Here you can see physical quantities. To express the physical quantities, not only we require three, but mass, length, time, we require the other units also we require. Other units are also we require to express the which one? Physical quantity. Now what is the meaning of the physical quantity? Physical quantity must be something that can be measured using the instrument or techniques. With the instrument or techniques, we can, which one? We can derive the physical quantity. First one, you can see this is the time. Clear? These are the some physical quantities that we are having, that we can measure with the instrument or techniques. Clear? Here, what are the that basic fundamental units that we are having? These are the basic fundamental units. What are the basic fundamental units? First is a length. Unit is meter. Symbol is m. Next, mass, kg. Time, second. Temperature, Kelvin. Electric current, ampere. Luminous intensity, candela. And amount of substance, mole, and that is mole. These are the 7 basic fundamental units that we are having, and the remaining units that they will derive from this fundamental units, and the remaining units, that what we can do, we can derive from this fundamental units. Okay, now we'll see the derived units. What are the derived units, that how we can derive from the fundamental units? Now we'll see. First one, we are going to see area. What is the area? Area is length into breadth, right? Length into breadth. So this is a length is a meter and the breadth is also meter. So area unit will be the meter square. Area unit will be the meter square. Clear? Next derived unit. Now we'll see volume. What is the volume? Volume is equal to L into B into height, right? Length into breadth into height. So M into M. So volume unit will be meter cube, that we know. Next, this is second, and the third unit that we are going to study, that is density. What is the density? Density is the mass by volume. Mass by volume. Mass is kg and volume is meter cube. Clear? This is kg meter cube or meter inverse cube. Clear? Done. Next one, kg meter inverse cube. Now next, fourth we are going to see. What is the fourth we are having? Fourth we are having the speed. What is the speed? Speed is distance covered by time. Distance covered by the time. Distance covered will be equal to meter. Clear? And time taken is a second. Time taken is a second. So acceleration is equal to meter second inverse. Meter second inverse. Clear? Now fifth one. Fifth one, we are having the acceleration. Acceleration is a, what is? Change in velocity by time taken. Time taken. The change in velocity will be the meter second inverse by second. This will give you the meter second inverse square. Second inverse square. Clear? Now this is a unit of the acceleration. Next, sixth we are going to see, that is force. This is force. Force is a mass into acceleration, right? Mass into acceleration. Clear? Mass into acceleration. Here what is a mass unit? Mass unit is a kg. Done. Now what is the acceleration unit? Meter second inverse. Meter second inverse. Now this one we call it as a kg meter second inverse, right? Kg meter second inverse. This, the SI unit of the force is Newton. SI unit of the, which one? SI unit of the force is which one? Newton. This is Newton. This is the unit of the force. Clear? Next we are going to see very important one, that is pressure. That is pressure. What is the pressure? Pressure is a force by area. Pressure is a force by area. Now what is the unit of the what is the unit of the force? Just now we have seen kg meter second inverse square. Second inverse square. Now what is the unit of area? Area is meters square. Meter square. This one we can say it as a kg meter inverse and the second inverse. Second inverse. Or we can say this as a Newton meter inverse square. Newton meter inverse square. Clear? Now SI unit of the pressure is Pascal. Clear? This one you call it as a, this one what we call it? This one we call it as a Pascal. Clear? Done. Next. eighth we are having, that is energy. That we are having energy. What is the energy? Energy is equal to force into distance traveled. Force into distance traveled. What is the force unit? Force is equal to kg meter second inverse, clear, second inverse square, into distance traveled will be the meter. Then this one will be equal to kg meter square second inverse square, clear. Now SI unit of the joule, SI unit of the energy is joule, clear. This one we call it as a joule. Done, clear. Now these are the some derived units we are having. Now after that derived unit, next we are going to study very important one. What is that? Unit conversions. Now what are the unit conversions we are going to study? Now you see, these unit conversions will play very crucial role in the calculation purpose. So what are the unit conversion that we are studying? First one, so unit conversions. So how to convert the unit conversions? Now you see here, whenever I will say you one trick, if you follow this trick or if you remember this one, you will never and ever you will make the mistake in the unit conversions. First one, whenever you are going from the smaller unit to the higher unit, smaller unit to the higher unit if you are going, then smaller unit to the higher unit if you are going, that it will become, what it will become? If you are going from the smaller unit to the higher unit, that it will become 10 to the power negative value, it will be there. 10 to the power negative it will be there when smaller unit to the higher unit. Now if suppose if you are coming from the higher unit to the smaller unit, higher unit to the smaller unit, that will be the 10 to the power positive will be there. 10 to the power positive will be there. Sir, I did not understand. Okay, I will explain very clearly. Now you see, here I will go with your well-known example. Generally we used to use generally daily, right? That well-known example for you. It is gram. You take gram. Gram is a smaller unit and kg is a larger unit. Clear? Now 1 gram is equal to 10 to the power minus 3 kg, right? 10 to the power minus 3. See, from the smaller unit, when you are going to the higher unit, 10 to the power minus 3. Okay. Now from the higher unit, if you are going to the smaller unit, means 1 kg will be equal to 10 to the power 3 grams, right? 3 grams. Clear? Done. In that manner we have to see. If you are going from the smaller unit to the higher unit, it will be 10 to the power minus. If you are coming from the higher unit to the smaller unit, that will be the 10 to the power plus. Clear? Done. Now based on this, the first conversion that we are going to see, the volume conversion. This is very important, very important, and it will make you more confused, and very high times or more times we are going to use these conversions in the mole concept. These conversions will play very important role, and the volume conversions will play very important role. Now you listen how the conversions, and I will derive each and every volume conversion very elaboratedly to make you to understand. Okay. Now you see, first in the volume conversions, what it will be there? First is the ml. Okay, if you go from the ml to liter, that it will become 10 to the power minus 3, that we know. And from the liter to, if you go to the cubic meter or meter cube, cubic meter if you go, then again it will become 10 to the power minus 3. Clear? Done. Now here suppose if you are coming from where, if you are coming from the meter cube to the liter, that it will become 10 to the power plus 3, and liter to milliliter if you go, that it will become 10 to the power plus 3, 10 to the power plus 3. Now you see, so can I say 1 ml is equal to 10 to the power minus 3 liters, minus 3 liter equal to 10 to the power minus 6 meter cube, can I say, or cubic meter. Then this one we can say it as a cubic meter also, cubic meter. Then now 1 ml is equal to 10 to the power minus 3 liter or equal to 10 to the power minus 6 meter cube. Done. Now here this is very important conversion. Now based on this, now we'll see how the conversions we are having. First, here what I will prove you that 1 ml will be equal to 1 centimeter. 1 ml is equal to 1 centimeter and 1 liter will be equal to 1 decimeter cube. 1 ml is equal to 1 centimeter, 1 liter is equal to 1 decimeter cube. How they are equal? Now I will derive it and I will make you understand very clearly. Now listen. First, we know 1 liter is equal to 1000 what? 1000 ml. This 1000 ml is equal to 1000 cc, we can say, cubic centimeter, or 1000 centimeter cube, 1000 centimeter cube. First I will derive how the 1 liter will be equal to 1 decimeter, and 1 ml will be equal to 1 centimeter. Clear? Now you see, here can I say this one, what can I say? 1 meter is equal to 10 to the power 2 centimeter, can I say? This is right, 1 meter. Higher unit to the lower unit you are going, power will be in the positive. Then when you are coming from the lower unit to the higher unit, then 1 centimeter will be equal to 10 to the power minus 2 meter, can I say? Done. For 1 centimeter, for the 1 centimeter, if I do a square or cube, if I do a what? Oh, better. Now, here 1 centimeter, right, 1 centimeter is equal to 10 to the power minus 2 meter, right? Now here this one is a 1 liter is equal to 10 to the power 3, can I write? 10 to the power 3. Now what is this? 1 centimeter is equal to 10 to the power minus 2 meter, right? In the place of centimeter, can I write 10 to the power minus 2 meter whole cube? I can write, right? Then this one, what it will become? 10 to the power 3 into 10 to the power minus 6 meter cube. 10 to the power 3 into 10 to the power minus 6 meter cube. Then this one will become, what it will become? 10 to the power minus 3 meter cube. 10 to the power minus 3 meter cube. Then this one, can I write 10 to the power minus 1 meter whole cube? 10 to the power minus 1 meter whole cube. Now this one, can I say 10 to the power minus 1 is a deci. So 1 liter is equal to 1 decimeter cube. 1 liter is equal to 1 decimeter cube. Clear? Done. 1 liter is equal to 1 decimeter cube. In this manner, 1 liter will be equal to 1 decimeter cube. So 1 ml will be equal to 1 centimeter. 1 liter will be equal to 1 centimeter. Clear? Now here also, for this one, can I make that one? If I make, can see 1 centimeter is equal to 10 to the power minus 2 meter, right? For this one, if I do a whole cube, then 1 centimeter will be equal to 10 to the power minus 6 meter cube. 10 to the power minus 6 meter cube, right? Then you can see here 1 ml will be equal to 10 to the power minus 6 meter cube, right? 1 ml is equal to 10 to the power minus 6 meter cube. Done. So here also 1 centimeter is equal to 10 to the power minus 6 meter cube. So I can say 1 centimeter will be equal to 1 ml, right? 1 centimeter will be equal to 1 ml. 1 centimeter will be equal to 1 ml. So by that can I say this one 1 liter is equal to 1 decimeter cube. Then 1 decimeter cube is equal to 1000 ml. 1000 ml is equal to 1000 cc. This 1000 cc will be equal to 1000 centimeter cube. Clear? This is about the volume. This is about the which one? Majorly about the volume. Clear? Now next we are going to see which one? We are going to see about the weight. Next we are going to see about the weight. Now in this weight we are having, now in this weight conversion, from where to where we are going to see in the weight conversion? First, second one is a weight conversion. In this weight conversion, the first we are having milligram. From the milligram to, if you go to the gram, from the gram will go to the kg, from the kg will go to the ton. Clear? Now from the ton, if you come to the kg, from the kg you can come to the gram, from the gram you can come to the milligram. So what I said, if you go from the lower unit to the higher unit, then it will be the 10 to the power negative, right? How much negative? 10 to the power minus 3. If you are going from the milligram to gram. If you go from the gram to kg, that will be 10 to the power minus 3. Clear? Again, if you go from the kg to ton, that will be the 10 to the power minus 3. Okay. If you come from the ton to kg, from where to where? You are coming from the ton to kg, then it will become 10 to the power plus 3. Clear? Now kg to gram, 10 to the power plus 3 gram. Then gram to milligram, 10 to the power plus 3 milligram. So I can say that 1 kg will be equal to 10 to the power 3 grams or equal to 10 to the power plus 6 milligrams. 10 to the power plus 6 milligrams. This I can say, right? 1 kg is equal to 10 to the power 3 grams and equal to 10 to the power 6 milligrams. Is it clear up to now? Done. Now here next can I say 1 milligram will be equal to 10 to the power minus 6 kg. This is a very unit conversion. This it will very crucial role it will play in the structure of atom while we are doing the calculations. Okay, these units will play a very important role over there. Done. Next one. Next we are going to see the which one? Length conversion. Second, third one we are going to see, that is length conversions. Okay, done. In these length conversions, before going to the length conversions, I want to show you, or I want to define you some units. What are that one? See, here you can see submultiple units you want to see. Clear? What are the submultiples? It is deci. Deci means 10 to the power minus 1. Next is the centi. Centi is 10 to the power minus 2. Next is a milli. Milli is 10 to the power minus 3. Next is a micro. Micro is 10 to the power minus 6. Next nano, 10 to the power minus 9. Next pico, 10 to the power minus 12. Femto, 10 to the power minus 50. Clear? Now up to now you can remember up to here. up to femto, but in our chemistry max to max we will use only up to picometer or pico, up to pico we will use. Clear? Now after that, next I want to show you some abbreviated words. Clear? What are the words or units are that words we are going to use? First one is a alpha, that we will represent with this one alpha. Next one is a beta, next one is a gamma. This all you know, alpha, beta, gamma. Next one is a delta. Clear? Next one you can see here, next one we are having the epsilon. This epsilon most probably we are not going to use in our which one? Chemistry. Clear? This zeta, eta, theta, this all most probably we will not going to use up to iota. This kappa we will use, kappa, lambda, mu. Clear? This kappa we are going to use in the electrochemistry. It will play very crucial role in the electrochemistry, where this kappa will play very important role in the electrochemistry chapter. Kappa is K, lambda and mu. Clear? Mu. Clear? Next one is a nu. This nu also we are going to use. And the next one pi we know, and the remaining we are not going to use in our which one? In our chemistry. Clear? I hope you have cleared with the some units. These are the deci, centi, milli, micro, nano, pico, femto, and some Greek alphabets also we have seen: alpha, beta, gamma, delta, kappa, lambda, mu, nu, pi. Clear? These are the some Greek alphabets we are going to use in our which one? Chemistry. Clear? Now by this, now you come to the which one? Length conversions. In this length conversions, first is a which one? Millimeter. First one is a which one? Millimeter. Okay. From the millimeter you are going to the centimeter. From the centimeter we are going to the meter. From the meter we are going to the kilometer. Done? Done. From the millimeter, if you go to the meter, what? 10 to the power how much? Minus 1 millimeter is equal to 10 to the power minus 1 centimeter. From centimeter, if you go to the meter, that is 10 to the power minus 2 meter. That meter, if you are going to the kilometer, that will be the 10 to the power minus 3 kilometer. Clear? Then if you commit to the reverse, that will be the 10 to the power plus 3. Now year to year 10 to the power plus 2. Now year to year, that will be the 10 to the power plus 1. 10 to the power plus 1. Clear? Now here just now we have seen the submultiples, right? Down. With that one, now we are going to see, here we are having some length units that repeatedly that we are going to use in our structure of atom. That is, first one is a 1 angstrom. 1 angstrom. 1 angstrom will be equal to 10 to the power minus 10 meter and 10 to the power minus 8 centimeter. Clear? 10 to the power minus 10 meter and 10 to the power minus 8 centimeter. So how this 10 to the power minus 8 centimeter it has came? Now just now we have studied 1 meter is equal to 10 to the power 2 centimeter. You substitute this 10 to the power 2 centimeter here, then it will become 10 to the power minus 10 into 10 to the power whole cube centimeter, sorry, whole square into centimeter, right? Then it will become 10 to the power minus 8 centimeter. Okay. Next one is a 1 nanometer. 1 nanometer will be equal to 10 to the power minus 9 meter and 10 to the power minus 7 centimeter. Clear? Next one, 1 micrometer will be equal to 10 to the power minus 6 meter and 10 to the power minus 4 centimeter. Clear? 1 picometer will be equal to 10 to the power minus 12 meter and 10 to the power minus 10 centimeter. Clear? These are the length units that we are going to use in our chemistry. More than this we are not going to use other than this one in our chemistry. Clear? Next one we are going to use, or next type of the conversion that we are going to see, that is temperature. If suppose if they have given the temperature, how to convert the units of this temperature, now we are going to see. Clear? Now here in this temperature, first one, the conversion of the temperature, that is Kelvin. If suppose if you want to convert into the Kelvin, what? This is degrees Celsius plus 273 will give you in the Kelvin. If you want to convert into the degree Celsius, this is something, degree Celsius, then degree Celsius will be equal to K minus 273. This is a unit conversion of the temperature. And another type of the conversions of the temperature, it is also there, that is Fahrenheit scale. Fahrenheit scale. Now conversion of the Fahrenheit scale. The conversion of the Fahrenheit scale in the degree Celsius will be equal to 5 by 9 into Fahrenheit scale minus 32. Clear? If you want to convert into the degree Fahrenheit, then it will be equal to 9 by 5 into degree Celsius plus 32. Clear? This is a conversion of the temperature. Next type of the conversion we are having, that is pressure conversion. Clear? Now in this pressure conversion, that we are having what? 1 atm is equal to 760 torr, or this 760 torr will be equal to 760 mm of Hg, that it will be equal to 760 centimeter of Hg. This it will be equal to 1.013 into 10 to the power 5 pascals. Clear? Now these are the units of the pressure. Sir, how this 1 atm will be equal to 760 torr and the 760 mm of Hg means, actually the history behind this one I will explain how this it has came. Now how this 760 mm of Hg it has came, I will explain clearly. Now you listen. Here experimentally, to calculate the pressure, the instrument we used it as a barometer. Okay, in the barometer what they have taken, roughly I was explaining. Now let's suppose this is one in the barometer, there is one Hg column, this is some Hg rough instrument I was giving. Okay, now when this barometer instrument with the Hg column filled with this is Hg column, this is Hg, now filled with the Hg, that barometer, when they have taken to the deep sea level, barometer when they have taken to the deep sea level, in the deep sea level what it will be there, very high pressure will be there, very high pressure. Then when the pressure is high, then what it will happen, from this pressure is exerting here, this Hg column will be raised, Hg column will be raised in the barometer. How much Hg column has been raised in the barometer, that will be the 1 atm pressure, that will be the 1 atm pressure. So the pressure will be equal to what? Height of Hg column raised by 760 Hg column raised in the mm, that is atm. Clear? Now here experimentally they found that this barometer has been raised at the deep sea level is 760, is the 760, P is equal to 760 by 760, that it will give the atm. Sir, I did not understand anything, sir. Okay, if you understand it is well and good, if you are not understand also well and good. When the chapter called the states of matter, when we start, there I will explain very clearly. Okay, but just to rough idea, sir, how this 760 mm of Hg it has came, I explained. Actually there I will explain very clearly. Okay, done. Now I hope you have understand all the unit conversion which we have explained. By that we are going to end our lecture. Okay, bye.